5.3 properties of logarithms. Okay, so we got log base b, just like this. If we have a change of base formula, I'm going to show you two different ways that you can do this on your calculator. Not everyone's going to have the easy way, but if I'm asking for a change of base, if I'm asking for a change of base, you must write it. You can't just write out the answer. As long as you have the same base on top and bottom, like so, you can take the log of the large number divided by the log of the base number. Now, this is true as long as the base that you're dividing by is the same. So if I had a log, I can use the natural log because both of these are base e. So if I want to evaluate this when I'm writing this out, remember if there's no number, this is always going to be a log base 10. So I can do log base 10 on the top, divide by log base 10 of 4 on the bottom. Again, log of the large number divided by log of the base number. And I plug that into my calculator. So if I plug it into my calculator, your log button is down here, right there. So I have log of 25, close that parenthesis. Do not forget to close that parenthesis. Divide by log of 4. So right there, usually I want you to have it to the nearest 4 decimal spots. So 2.323, 4 decimal spots would be 19. Again, I could rewrite this because this could also be using the natural log. So the natural log of 25 over the natural log of 4. If I plug that into my calculator, my natural log button is right there, ln. So natural log, again, close that parenthesis. Make sure you're reading your equation correctly. So this is the same answer. So this is equal to both of those. Right now, I want you to pause the video and try to come up with C and D by yourself. So these are your two answers. Now, I'm also going to show you something that not all calculators have, but if yours does. If I ask you to solve this right here, you can do the change of base just like that. You could also see if you have the base button. So if I go to math, and if I arrow up right here, log base. Now, if when you push enter, if it does not come up with a little box right here, then you do not have the log base button. So this, I can actually put in my little 5 and then arrow over and I can put in my 30. And I still get that 2.113 and that rounded up to 3. Now, reviewing properties of logarithms. Now, just like our properties of exponents, it's going to be like the same thing. If it's multiplying on the inside, if I wanted to write it out larger, then it would be adding in between each term. So the same properties are for the logarithms with base 8 or your common log or natural log. So again, common log is that base 10. If I'm dividing, that means it would be subtracting in between. And if I have a power, that moves out in front and becomes multiplication. And that same property is for both. So first, this is saying rewrite this in terms of 2 and 3. So at first, I would have to rewrite this so it says what that is. So right there is 2 times 3. So because it's multiplying right here, this would be the natural log of 2 plus, because that's multiplying, when I move it out, it's adding the natural log of 3. Notice how I write the natural log both times. It has to be in front of both terms. So again, if I want to rewrite this, this is the natural log of 2 over 3 cubed. So what I have here, I'm going to write it out 2 different times. So I have this natural log of 2. Because it's division, it's going to become subtraction. Now this, if this was a quiz or test and you left your answer like this is not full credit because this is not expanding the log as much as you can. Because this 3 then can come out in front using this last property right here. So my final answer would be natural log of 2 minus 3 times natural log of 3. Right now I want you to pause the video and try to do A and B. So your two answers would be 2 log 5 plus log 3. Here would be 2 log 3 minus 3 log 5. You know, one of the hardest parts is knowing how, when I'm breaking this up, knowing that 25 is 5 squared, knowing that 125 is 5 cubed. Again, that's just number sense. You just need to have practice with that. So here, I'm asking to expand this. So when I'm expanding, I'm looking to see where's the multiplication or division. Where's the power? So in between each multiplication, I'm going to have an adding. Notice how I'm writing my log base 4 for each one. If you forget that log base 4, that would be a point off. So make sure you pay attention to fine detail. Same here. This 3 now can come out in front of just the x. Again, just the x. If you put it out in front of everything, then that would not be correct. So this right here is my final answer. This one's a little bit more difficult. Because a lot of times people forget that a power can be written, or a root can be written as a power. This is like a 1/2. Notice how I'm not touching that. One thing too, even though there's multiplication here, this subtraction stops that. So I'm not going to be able to break this up any further. But what I can do is bring this 1/2 out in front. So I'm going to have this 1/2 out in front of just this 3x minus 5. Again, I cannot break that up any further because of the subtraction right here. I cannot break that up any further. Minus my natural log of 7. This does not have a 1/2 with it because it does not have a half here. It's not underneath the root. That's my final answer. Right now, I want you to try to do C by yourself. So you have log base 3 of 4 plus 2 log base 3 of x minus 1/2 log base 3 of y. So just like how we can expand, we can also condense. Notice how that 1 plus or x plus 1 is in parentheses, again, because you can't break any adding, subtracting up. You cannot break adding, subtracting up. One thing I would always tell people is first look for this multiplication. That becomes an exponent. The multiplication out in front becomes an exponent. So if I wanted to, I could rewrite this so it looks like this. And you should not leave any fraction exponent in your answer. Okay? You have to realize that a fraction exponent is going to be a square root. So I have the square root of x for this first one. And because this is adding right here, that means it's multiplying. You don't have to write that multiplication sign, but you sure can. And I have that x plus 1 to the third power. This right here is my final answer. So right now I want you to pause the video and try to do B by yourself. So right here I have my x plus 2 squared because that becomes an exponent, and then because of the subtraction, it is division. Now this one's a little bit more tricky because of this 1/3 in front of this whole thing. You also have to remember again that this 1/3 is going to be a cubic root. So first I'm going to focus in on this. So I'm going to have this 1/3 out here. I'm going to condense this together. So I'm going to have my log base 2, and then because of this adding right here, this becomes multiplication. So this is what I have right now. And because this 1/3 is a root, so I could write it up here, but I'm not going to write a fraction exponent because Mrs. Frickman will get mad at that because I have to know that a fraction exponent is a root. So again, I have that x plus 1. So far I have a square root. Because it's a 1/3, though, I need to have this as a cubic root. And this 1/3 becomes 1/3 exponent, which is actually a cubic root. And that's what we have for today. Have a great, have a wonderful day.